Hello friends, welcome to H2 Diamond Academy. In the last lecture we have discussed up to question number 2. So we will discuss question number 3 onwards in this particular lecture. So basically we are discussing the problems on the virtual work. So let's start our discussion. So what is given in question number 3? So 4 uniform rods, each of equal weights. Okay, each of equal weights W are freely jointed to form a rhombus ABCD. The framework is suspended freely from point A and a weight capital W is attached to each of the joints B, C and D. So let us draw a rhombus. So we have a rhombus like this. Okay, we have a rhombus ABCD. So this is A, this is B, this is C and this is D. Okay, and the weight capital W is attached to each of the joints B, C and D. So let us apply the weights here. So we have the weights as capital W at B, C and D. Okay, and we have the weight of the rod as small w. Okay, so it will act at the center of gravity of a particular rod. Okay, so the midpoint of AB is this point, and we have this is the midpoint of BC, this is the midpoint of AD. Okay, and this is the midpoint of CD. Let us apply the weight as small w. This is small w, this is a small w, this is a small w, and this is a small w. Okay, so because of this whole system of weight, this point B and D will try to move in outward direction. Okay, so for preventing the movement of B and D in outward direction, a force P as given in the question is applied in inward direction. Okay, so because of this whole system of weights, the point B and D has potential to move in outward direction. So we have applied a force P so as to prevent the movement of B and D in outward direction. Okay, as simple as that. Now we have the weight of the rod as small w. Okay, so it is being applied at these particular points. Okay, so we can replace this with a combined weight of 4w. Okay, 4w at point O, and point O is the point where diagonals are meeting. Okay, so now we can rub this. Okay, so now we have forces as force P, and we have combined weight 4w, and we have weight capital W at B, C and D. Let us write down the virtual work. So we have virtual work is equal to force times of virtual displacement. Okay, so we have, let us take the force P. So P times of virtual displacement. Okay, so we have BD as BD. Let us calculate BD. So for this calculation, let us take the length of the rods as 2a. This is 2a, this is 2a, this is 2a, and this is 2a. Okay, so let us read the question once again. So we have, if two horizontal forces, each of magnitude P, acting at B and D, keep the angle BAD is equal to 120 degree. Okay, so BAD is, this force is applied in such a way that angle BAD is 120 degree. Okay, so half of the angle is 60, half of the angle is 60. Okay, so for time being, let us take this angle as theta. Okay, and after calculation we will put theta is equal to 60 degree. Okay, so now we have this BD. Let us calculate the length BD. So we have BD as equal to, so this is 2a and this is theta. So this is 2a sine theta. This is also 2a sine theta. So BD is equal to 4a sine theta. Okay, now for this 4w, we have to take the length as AO. So AAO is equal to 2a cos theta. Okay, and for this one W, because we have taken the reference point as A. Okay, so we have taken the reference point as A for writing the virtual work. Okay, so we have this force times of displacement. So displacement will be, virtual displacement will be change in BD. For 4w we have to take this distance. Okay, so 4w times of this distance. Okay, Let us write down. So P times of change in this BD. Okay, BD plus 4W into change in this one AO. Okay, plus now we have weight capital W. Okay, so let us take this as capital W times of this distance OA, AO, change in AO. Okay, similarly for this one, capital W times of change in OA, so AO. So let us take this as 2 times. Okay, plus this one, capital W times of change in this whole distance AC. So AC is equal to, this is 2A cos theta, this is 2A cos theta, this is 4A cos theta. Okay, change in 4A, change in AC. Okay, so now let us place the value. So we have virtual work is equal to P times of change in BD is 4A sin theta, plus 4W times of change in AO is 2A cos theta, plus this is AO is 2A cos theta हो गया. उसके बाद प्लस 2 कैपिटल W इंटू चेंज इन AO is 2A cos theta plus capital W times of change in AC is 4A cos theta. Okay, this is differential change of this value. Similarly, these are the differential change in particular distance. Okay, force times of distance. Now let us further simplify this. So we have the virtual work as is equal to, this is P into, this is differential change of 4A sin theta. So this is 4A cos theta plus 4W into 2A times of minus sin theta. Okay, differential change of cos theta is minus sin theta plus 2 capital W into 2A cos theta का minus sin theta. Okay, plus capital W times of 4A into, this is cos theta, so this is change in cos theta is minus sin theta. Okay, and as per principle of virtual work, this value is 0. So 0 is equal to, okay, this is 4A P cos theta, this is minus 8A sin theta, this is minus 4A capital W sin theta, this is minus 4 capital W 4A capital W sin theta. Okay, so we have this as, let us divide this by 4A. Okay, so 0 is equal to P cos theta minus 2 small w sin theta minus capital W sin theta minus capital W sin theta. Okay, so we have P cos theta is equal to, let us take this all these as left hand side. Okay, so this is 2W plus 2 capital W sin theta. Okay, so P cos theta is equal to 2 times of W plus capital W sin theta. So from here P is equal to 2 times of W plus capital W. This is sin theta upon cos theta. So sin theta upon cos theta. So this is equal to, P is equal to small w plus capital W into 2 times of tan theta. Okay, and we have theta is equal to 60 degree. Okay, so P is equal to W plus capital W into 2, and tan 60 is equal to root 3. So this is 2 root 3. This is the value of P. Okay, now let us discuss question number 4. So what is given in question number 4? Four equal uniform rods, each of weight capital W, are joined to form a rhombus ABCD, okay, which is placed in a vertical plane with AC vertical and A resting on a horizontal plane. The rhombus is kept in a position in which BAC is equal to theta by a light string joining B and D. Find the tension in the string. Okay, so let us draw the rhombus. So we have four uniform rods, each of weight capital W, are joined to form a rhombus ABCD, which is placed in a vertical plane with AC vertical. Okay, so we have this point as, and A is resting on horizontal plane. So this point is A, this is B, this is C, and this is D. Okay, each of weight capital W are joined to form a rhombus. So we have weight of this is capital W, this is capital W, this is capital W. Weight of the rod, it will act at the center of gravity of a particular rod. Okay, rhombus is kept in position in which BAC is equal to theta. So BAC, this is theta. So since it is symmetrical, this will also be theta. Okay, find the tension in the string. Okay, the rhombus is kept in position in which BAC is equal to theta. Okay, let us read this again. Four equal uniform rods, each of weight capital W, we have applied capital W, are joined to form a rhombus ABCD, which is placed in a vertical plane with AC vertical. AC is vertical and A is resting on horizontal plane. The rhombus is kept in a position in which BAC is equal to theta by a light string joining B and D. So this is our light string. Okay, this is light string. Okay, find the tension in the string. Okay, so because of these weights, this point B and D will try to move in outward direction. So a tension T is being applied in the string so as to restrain the movement of B and D in outward direction. Okay, so we want to prevent the movement of B and D in outward direction. So we have tied a string to B and D. Okay, so the tension will act in inward direction. Okay, so the combined weight of this W will act at this particular point, that is the point where diagonals are meeting. This is for capital W. Okay, so we have the forces at tension and for capital W. Okay, so the virtual work will be force times of virtual displacement. Okay, so now let us take the let us rub this, because we have taken the combined weight. Okay, combined weight as 4W. Okay, now the work done, virtual work done due to tension T and 4W is negative, because displacement is in opposite direction of force. Okay, so now let us write down the virtual work done. So before this, let us take the length of the rod as 2a. This is 2a, this is 2a, this is 2a, and this is 2a. Okay, so we have tension times of this distance. So BD will be, this is theta, this is also theta, this is also theta, as it is symmetrical. So BD is equal to, this is 2a, this is theta. So this is 2a sin theta. This is also 2a sin theta. So BD is equal to 4a sin theta. Okay, and we have for 4W, for capital W, we have the distance as this one. Okay, so we have taken the reference point as let us take the reference point as A. Okay, so we have AO as AO is equal to 4W, force times of distance. So this is OA. AO is, this is 2A, so this is 2A cos theta. This distance is, this is 2A, so this is theta. So this is 2A cos theta. Okay. So we have the virtual work as, let us write down. So we have the virtual work as, virtual work is equal to tension times of, the work done is negative, so this is minus of tension times of change in this BD. And because of 4W, work done is also negative, so this is minus of 4W times of change in this AO. Okay. Okay. And as per principle of virtual work, this value is 0. So 0 is equal to minus T times of change in BD. BD is 4A sin theta minus 4W into change in AO. AO is 2A cos theta. This is equal to minus T times of 4A cos theta, and this is plus, this is 8AW into sin theta. Okay, so we have, this is 0. So let us divide this by 4A. So this is 2 times of. This is T cos theta is equal to 2W sin theta. Okay, so T is equal to 2W times of sin theta upon cos theta. So T is equal to 2W tan theta. Okay, so the tension in the string BD is 2W tan theta. Okay, so we have discussed up to question number 4. Okay, so this is all about the principle of virtual work. Thank you.